This is Mr. Beck Does Your Homework, AP Physics, Homework 5.3, Question 11. An object is dropped from rest from a height of 6.8 times 10 to the 6th meters above the surface of the Earth. If there is no air resistance, what is its speed when it strikes the Earth? The acceleration of gravity is that. The radius of the Earth is this. Answer in units of kilometers per second. So what I have is an object that starts off with some potential energy, and then I'm going to drop it, and it's going to turn into some kinetic energy. But since I'm going to do this above the surface of the Earth, above the center of the Earth, right, when it hits the surface of the Earth, so it's still got some universal potential energy of gravity here. So these two together equal this one up there. So my potential energy at the top is going to be this equal to my potential energy plus my kinetic energy at the surface. Now you can't use a potential energy of 0 and this being mgh, because this is high enough above the surface of the Earth that force of gravity has changed, so you can't use regular PE. Instead, you've got to use g, mass of the Earth, mass of the object, divided by the height of the object, and this r is going to be the total distance from the center of the Earth, and that's going to be the g times the mass of the object times the mass of the Earth divided by the new height, and this is going to be the radius of the Earth, plus my 1/2 mv squared, mass of the object times the velocity squared. Now, luckily, in this case, the mass still cancels out. The mass of the object still cancels out. So I'll call this the, well, by the way, this is the R1, and this is the R2. So this is the R up top, and this is the radius of the Earth. So I can call that RE. So this mass is the mass of the object. This mass is the mass of the object. Either one, it doesn't matter. But this is definitely the mass of the Earth. So when I'm solving for V, I'm going to get G times the mass of the Earth divided by the radius, how high the object was, minus G times the mass of the Earth divided by how high the object now is, which is the radius of the Earth, equals 1/2 v squared. Now you know G, the mass of the Earth, you know from a previous problem, is 5.98 times 10 to the 24th kilograms. So the mass of the Earth equals 5.98 times 10 to the 24th kilograms. So that you'll need in this problem. Now I could be sneaky and factor this out and get G times the mass of the Earth times 1 over the height of the satellite initially minus 1 over the radius of the Earth equals 1/2 v squared. The initial height of the satellite is going to be, so R1, I'll put that over here, R1 is going to be my 6.8 times 10 to the 6th plus my radius of the Earth, which is 6.37 times 10 to the 6th. It's going to be that whole distance above the surface, above the center of the Earth. So that's what this R1 is, and the radius of the Earth is just this much. There's some more algebra you can do, but I think this would be the easiest way to do it. So that G, mass of the Earth, is 1/2 v squared, multiply by 2, square rooted, and you will get yourself a speed of that object when it comes and strikes the Earth. And then before you plug in this velocity, remember it said kilometers per second. So whatever this velocity is, divided by 1,000, because this velocity was meters per second. If you divide by 1,000, that'll give you kilometers per second.